4.5 mid-segment. So in our last set of notes earlier this week, we looked at 4 special segments in triangles. That was the median, which connected a vertex to a midpoint, the altitude, which connected the vertex to the opposite side at a 90-degree angle, the perpendicular bisector, which did not have to go through a vertex, but it bisected a side at a 90-degree angle, and the angle bisector, which bisected the angle that it went through. Okay, so the 5th special segment we're going to look at, it gets its own set of notes today because we're going to go a little more in depth with it, is the mid-segment. Okay, so what a mid-segment is a line segment that connects 2 midpoints. So a real common one for students to mix up is the mid-segment and the median, because a median goes through a midpoint as well, but it goes from one midpoint to the opposite vertex. Okay, the difference with a mid-segment is it's 2 midpoints. Okay, so if you want to highlight or outline or underline part of the word, okay, it's got mid in it. Okay, so it's midpoints. Mid-segment connects midpoints, if that helps you. In every triangle, just like with the medians and the altitudes and everything, you could have 3 different mid-segments. Okay, so you can see in this image to the left, the dashed lines are the mid-segments. Okay, because D, E, and F are the midpoints of the sides of triangle ABC. And when you connect midpoint to midpoint, okay, these are mid-segments. So there's 3 mid-segments in a triangle. When you draw all 3 of those, how many triangles are created in here? How many smaller triangles do you see? 4. Okay, there's 1, 2, 3, 4, smaller one. Okay, and those 4 smaller ones that are created when we draw all 3 mid-segments, those are all congruent. They're all the same size triangle. Now, if you can visualize it, I'm going to do some highlighting over here. Okay, these 3 that go around, that come from one of the vertex, those 3 look the same, don't they? They're drawn in the same direction, aren't they? Okay, the same slant to them and everything. But that one in the middle it is congruent, but it's just oriented differently. Do y'all see that? It's rotated upside down. It's rotated 180 degrees. So if I took any of these that I highlighted in blue and rotated it, okay, 180 degrees, so half a circle, half a rotation, it would look like this green one. Does everybody understand that? Can you visualize that? Okay, so those are all 4 congruent to each other. And we're going to come back to this image after we go over this theorem. So the triangle mid-segment theorem tells us that a mid-segment of a triangle is parallel to a side of the triangle. Okay, so in this image down here, we've got one mid-segment drawn. Which side of the triangle ABC does that appear to be parallel to? AB, BC, or AC? What does parallel mean? The same what? Same slope, so they're running in the same direction. Do parallel lines ever cross, ever intersect? No. So this DE, it's intersecting side AB, isn't it? At point D? And it's intersecting side BC at point E? Because D and E are the midpoints of those sides. So the side that it doesn't intersect, that it's running the same direction as, is AC. Okay, so these are parallel to each other. Okay, they have the same slope. They're never going to intersect. Now, the reason that that's important is because it tells us about some of these angles created in these smaller triangles. Because remember with parallel lines and transversals, that's what we just tested on in Unit 3, right? If I look at this as a transversal over here, this side, okay, wouldn't, for instance, this angle correspond to this angle? Y'all agree? Okay, and this angle would correspond to this angle, yes? Okay, that's why the parallel lines matter. You don't have to leave those angle markings there. You can if you want to, okay, but why the parallel feature of this mid-segment theorem matters is because of the angle measures. It helps us, it creates these congruent triangles because the angles in these little triangles are all going to be the same as each other. Okay. The other thing the mid-segment theorem says is that not only is this parallel to this third side, okay, its length, the length of DE is half the length of that side that it's parallel to. Okay, so that's what's written here in math terms. Remember, this is our parallel symbol. So DE is parallel to AC, and DE is half of AC. So that's talking about the length. Now, that's saying if I wanted to find DE and I knew AC, I could take half of AC to get back to DE. Yes? It works in reverse as well. What if I'm trying to find AC and I know DE? What would I do with this length to find the length of AC? Let's say this length was 3. What would the length of AC be if this is the relationship? What is 3 half of? 6. So to get from 3 to 6, what did you do? To get from 6 to 3, you took half. But what about to get from 3 to 6? What's the opposite of taking half of something? From 3 to 6, it's getting bigger. Dividing, taking half of something is dividing by 2, right? What's the opposite of dividing? Multiplying. So instead of going from AC and dividing by 2 to get to DE, to get from DE to AC, you can multiply by 2. So I'm going to write that here as well. I'm going to say you could get your side length by taking twice your mid-segment length. Okay, so this is what I was trying to get y'all to understand. Okay, going from if you know the short one, double it to get the side. If you know the side, half it to get the mid-segment. You can go both directions between the two if you understand their relationship. Now, back to this image up here on the top left, let's look at that. So with these mid-segments that are drawn, DF here is going to be parallel to AC. Now, if E is cutting AC in half and we put 3 tick marks on each half, wouldn't it make sense that we could put 3 tick marks on DE? Because isn't DF? Isn't DF going to be the same as half of AC? And each half has 3 tick marks. Y'all understand where these 3 tick marks came from? I need a response because I have no idea if you understand what I'm saying. Do you know, does it make sense that I can mark this DF congruent to AE and EC?
Yeah.
Okay, thank you. So I can do the same thing on all the sides. So side AB, for instance, is cut in half by D, and they put 1 tick mark on each half. So I could put 1 tick mark on EF, which is the mid-segment that runs parallel to it. So how many tick marks could I put on DE? 2, because it's running parallel to BC. So I know DE is going to be the same as half of BC, which each half has 2 tick marks. So this could have 2 tick marks. These tick marks are going to come in really handy. So I want you to understand which ones are going to have matching tick marks, which ones are congruent. So far, so good? Okay. All right. So I'm going to put my tick marks on here before I even look at any of these questions. When I'm given an image with mid-segments, I'm going to mark it up so I know what's congruent to what. Okay, so I'm going to put the way that they've drawn it, the 1 tick marks are here. So which mid-segment down here should I put 1 tick mark on? The one marked as 6.2, which is FD. Okay, which one should I put 2 tick marks on? Which one's going to be the same as these 2 pieces? BF, good. And then obviously the last one should have the 3. Because BD is going to be congruent to AF and FE. All right, now I'm going to do some color coding for us here. So they ask us, how does BD compare to AE? So BD is this mid-segment, and AE is the side that it's parallel to. So I'm going to write that they're parallel. And what do we know about their length? How is the mid-segment length going to compare to the side? It's going to be half of it, right? So I'm going to say that BD is half of AE. Now they actually want us to find BD here. I would have written these in a different order, but if we want to find BD, okay, let's see what AE is labeled. AE is labeled 17. So what am I going to do with this 17? Divide it by 2. I'm going to cut it in half. You can think of that as times 1/2 or divided by 2. Either way works. So I'm going to take that 17 and divide by 2. You can leave it as 17 over 2. If you divide that, it comes out to 8.5 as a decimal. Okay, so that means that each of these with 3 tick marks is 8.5 units long. Silas is going in and out here. Does that make sense? So far, so good? All right. Now it asks about what we know about BF and CE. So BF is here and CE is here. So what's their relationship? It's the same as BD to AE, isn't it? Mid-segment to the third side. This is the mid-segment to the third side. So these are going to be parallel, and the BF is going to be half of AE again. Now you can write it just like we wrote this part in red, but with our new letters, our new segment names, or you can put it in words. You can write out, because they didn't specify that it has to be in math terms. So you can say BF is parallel to BE. You can say that BF is half the length of CE. Okay, so when you have a question like this, I don't care if you write it in math terms like we did here in red or in words like we did in blue. Okay, those say the same thing. They tell us the same information. Okay. All right, now we're going to look at angles. So this is what I was getting at up here when I was talking about the parallel lines, and you look at the transversals. okay, to get all these different angle relationships. So when you have all three medians drawn, it gets a little mumble jumbled, okay? It can be confusing. So I'm going to do some highlighting. I don't want you to highlight what I do right now on your own paper because I'm going to erase the highlighting and then highlight something else. So I'm just going to highlight to draw your focus to a part of this picture since there's a lot going on. So let's start with the red. These are the parallel lines. And where that 26-degree angle is created, it's with this transversal here with segment FD. So do y'all see the part that I highlighted? Okay, we've got parallel lines and we're looking at this FD as the transversal. So when we have parallel lines and a transversal, remember the alternate interior angles are congruent. So this angle that's marked as 26 is going to be the same as this angle here. Y'all remember that relationship? It's like when you see that Z shape, it's the corners of the Z are going to be the same because these are parallel lines. Yes, we feel okay about that? Okay, so I'm going to erase this highlighting. So bear with me a sec. What if we look at this one over here as the transversal? So we have those same parallel lines, okay, but now we're going to look at this as the transversal. I need to highlight a little more of it there. Okay, we can look at corresponding angles. Corresponding angles are in the same corner. So like if these lines were to extend, okay, this would be like the top right corner and this would be the top right corner. So aren't these two angles going to be the same as each other? Oops, I did not want a crayon there. And a pen. So wouldn't this angle be the same as this angle? Do y'all agree? The ones that I put the dot on, those are going to be the same. Okay, so now let me move my highlighting to show you something else. If I focus on a different set of parallel lines, the blue ones here, and a transversal, it's not the transversal we want. Let's look at, I'm making sure I haven't already marked, it's the angle that I want to look at. Actually, these that I want to look at. These parallel lines and that transversal, because that's that 26-degree angle again. And now I've got another Z shape here. Okay, so 26 would be here. 26 would be here. Do y'all agree? And that's the one that I had the dot on that I said is going to be the same as this one. So that means this is going to be 26 also. Okay, so it's kind of being able to go, those parallel lines are what make it possible for us to find which angles are congruent to each other. Okay, so that's why the parallel lines matter. So I've marked, you can mark that. Okay, I'm done highlighting. So I want you to mark those angles that I marked in green. Those are all 26-degree angles. Those are all congruent to each other. Now, that was kind of confusing. I understand if you didn't quite follow or remember all of your transversal and parallel line angle relationships. Okay, there's a lot going on in this picture. So that's why I really want you to mark these tick marks, because now I'm going to show you something. Do you see where the 26-degree angle is marked? It's where the 1 tick mark side and the 3 tick mark side meet, isn't it? Does everybody see what I'm talking about? The 1 and the 3 meet here at 26. So in all of these triangles that we created, it's going to be where the 1 and 3 meet. So where the 1 tick mark and 3 tick mark meet, that's 26. Where the 1 tick mark and 3 tick mark meet, that's 26. Up here, where the 1 and the 3 meet, That's 26. So for a lot of y'all, for most of y'all, it's going to be easier to look at the tick marks on the sides to find the congruent angles rather than looking at the parallel lines and transversals. Okay, so this question up here asked about angle. I'm going to leave the highlighting I do now because it's asking specifically about this angle CBD. So C to B to D is this angle here. And that's one we marked 26, isn't it? So that's 26. And then this question down here asks us to compare, or it says, how does CBD compare to BDF? So B to D to F. If I trace B to D to F, that's this original 26 angle. So how do they compare? What would you say? How are they marked in the picture? How did I mark them? But in what geometry terms, what could we say about these? They are congruent. Okay, they're equal measure. They're congruent. That's what those green arcs were for. All of those angles with the green arc that I put, those are congruent to each other. Okay, so these are two of those. So those are congruent. Now, if you want to get more specific and talk about why they're congruent, what I showed y'all, you could say they are alternate interior angles. Okay, that's the reason they're congruent. Questions so far? All right, let's flip it over. So on the back here, we are given an image. I'm going to add my tick marks and then answer everything that they're asking for. So first off, I'm missing a mid-segment. What do I need to connect to draw my other mid-segment here? PR. PR. So I'm going to add that mid-segment, PR. And how many tick marks should I put on PR? 2. Good. Because it's parallel to this one up here, and those halves have 2. So this is going to have 2. If you want to color code your whole thing, you can if you use colors. So this one's going to be parallel to this. So how many tick marks should PQ have? 3. Okay, and then that one's not very straight. This one will have 1. Okay, and then the angle that's marked 55 is right here. If you want to put an arc on it to make sure that that's clear. I could go ahead and mark all the 55-degree angles. Okay, which two sides are meeting to make that 55-degree angle? How many tick marks are on them? Yep, the 1 and the 3. Mine are green and blue. So where all the green and blue on mine, or where all the 1 and 3 tick mark sides meet, those are all going to be 55. So I see 1 and 3 meet here. 1 and 3 meet here. So in those outer triangles, it's the same spot. It's the lower angle, right? But in that middle triangle, remember this one's rotated around. So it's rotated. So I have to find that 1 and 3. It's going to be at the top of that one. So far, so good? All right, so let's see now with what I've marked up on here to help guide me if I can answer all these questions. RJ is here. How long is RJ going to be? It has 3 tick marks. Do any of the other 3 tick marks have a label? This one right here, right? What is it? 19. So these are going to be 19. So you could label that in your picture, 19 and 19. So RJ is 19. And then GJ, that's this whole length from G to J. What are you going to do with those 19s? Add them together. So you get 38. Okay, the measure of angle H, I'll highlight this one here. HGH, or yeah, HGJ, H to G to J. So that is this angle. If I come all the way from H to G to J, you don't have to highlight the whole thing, but that's this angle down here. H to G to J. What does that measure? What did we mark it as? We put an arc on it because it's the same as 55. Okay, RQ. Let's see, RQ is there in green. It's the mid-segment in green. R to Q has one tick mark on it. Here's the side over here with one tick mark on each half. The total length is 27. What do I have to do with that 27? Divide it by 2. And so what do I get? It's 27, and this one's going to be a decimal. It's okay to have decimals. $13 and a half. So 13.5 for all of these. All right. HP. Where's HP? Is also in green. H to P right here. How long is that one? Also 13.5. Okay, now some angles. I'll get my highlighter back out. So angle P to Q to R. P to Q to R is here. This angle. What did we label that as already? We put an arc on it. What did that arc mean? 55. GPQ. So from G to P to Q. That's this angle here. That one's not marked, but what is marked next to it? 50. So if this is 55, and together, what should these add to? 1. So I'm going to do 180 minus 55 to see what's left for that pink angle. What's it going to be? One what? 25. Because if we do the 50 and the 30 would be 80, and then we'd have those 5s to be 90. So 125, because it was a linear pair with that 55-degree angle. Does everybody understand that? Okay. All right, one last one. Let's mark it up. I'm going to go ahead and put 74 down here on GR and RJ because PQ is marked as 74, and that one should be the same as half of GJ. So did they ask us for any of those? PQ, G, oh, there's GR, they asked for that. And RJ, no, they didn't ask for that. Did they ask? They asked for GJ. What's that total length gonna be then? What do I do with those 74s? Yeah, add them or do 74 times 2, so I get 148. Okay, so that's a good start. Okay, now I've got PR parallel to HJ, which HJ cut in half is 51. This piece is marked 51. So this will be 51. This will be 51. And so what would this total length over here be? Good. So let's see if they ask for any of that. Did they ask for, they did ask for PR. And they did ask for HJ. So we got those. Okay, so they didn't ask us anything about GH. So if you want to add your third mid-segment R to Q, you can, and it would have 2 tick marks on it. You're welcome to add it. They didn't ask us anything about it though. The remaining questions are all about the angles. So let's mark what is going to be congruent to this 71-degree angle here. It's where the 1 and 3 tick mark sides meet, right? It's where my red and green meet. So everywhere my red and green meet, I'm going to put an arc. All of those are the 71-degree angles. Let's see if they asked about any of those. So this one, GRP. So G to R to P. Yep, that's the here. That's where we have one of those arcs. So that is 71. RPQ. So R to P to Q. Yep, that's where we have one of the arcs. So that is also 71. And last but not least, then HQP. H to Q to P. Have an arc there. So that one is also 71 degrees. How do y'all feel? Okay. I'm not going to do a practice today since we don't really have time to work on it in class. We're going to do the last set of notes tomorrow. They are much shorter. They won't take very long. And then I'll just combine the 4-5 and 4-6 together into one practice. Okay. Any questions right now? Kind of make sense? I will go ahead and activate the practice if anyone wants to go ahead and start it. It'll be linked in Canvas, but you don't have to start it today. It won't officially be assigned till tomorrow. And I'm going to have 4.6 questions in there as well. So some of the questions, if you're like, I haven't learned this yet, if you try it tonight, it's probably because we're going to learn it tomorrow.